Multiple files are stored on the same storage device. So if we refer to the hard disk as the storage device, then the allocation method refers to how those blocks on the disks are allocated for the files. So the allocation to the files should be such that the storage space is utilized effectively and that the files can be accessed quickly and efficiently. So there are three major methods of allocating secondary storage space: contiguous, linked, and indexed. There are some systems which will support all three types of allocation methods, and it is more common to use one method for all files within a file system type. So in this video, we are going to take a look at the contiguous allocation method for files. So in contiguous allocation, each file will occupy a set of contiguous blocks on the device. Contiguous blocks means one after the other. Now we know that the device addresses, they have a linear ordering on the device. So the contiguous allocation of file is defined by the address of the first block and the length of the file, and this length of the file is also defined in terms of block units. So if, let's say, this is the storage space and this is the directory, as you can see that we are having multiple files on the storage device, and for each file which is allocated a contiguous set of blocks. So if you see over here, the start block is 0, and since the length of the block is 2, so 2 contiguous blocks are allocated to it on the storage device. So you can see that the start address is given and the length of the file in terms of how many blocks are being utilized by that file. This is specified in the directory. Let's take Mia. This is a file. It requires 5 blocks of storage space. So here is Mia, where the starting block address is 19. So 19, 20, 21, 22 and 23. So these 5 blocks have been allocated to Mia, and you can see that they are contiguous blocks. So the address of the first block and the length of the file is specified in the directory. So if the file is n blocks long and if it starts at location B, then it occupies blocks B, B plus 1, which is the next block, B plus 2, then the next block, then till B plus n minus 1. So these contiguous blocks will be occupied by this particular file. So the directory entry indicates the address of the starting block and the length of the area allocated for each file. The advantages of contiguous allocation is that accessing the file is easy. First of all, let's take a look at sequential access. So if the file system remembers the address of the last block that was referenced, and so whenever necessary, it can read the next block. Once it is at a particular block, say let's say it was at block 20, then it can, the sequential access to the next block, which is 21, then the next block 22, is easy. So the direct access to block I. If a file starts at block B, then the address of block I of that particular file is also known, because you add I to the starting address and then you can immediately access block B plus I. So the address can immediately be worked out if the starting address is known, and that particular block can be accessed. So if we assume that only one job is accessing this device, so accessing block B plus 1 after block B, that means this, if we are currently accessing block B, then accessing the next block, which is B plus 1, it requires no head movement. Let's suppose that currently we are on this particular track. This is block B, and let's say the next block is B plus 1. So for this, that means if block B is being accessed, the head of the disk is currently on that particular block and on that particular track. So now if B plus 1 has to be accessed, which is on the same track now, that means no head movement will be required. The head will simply remain at the same place. So if no head movement is required, that means there is no seek time that will be wasted. Only for moving from block B to B plus 1, there will be some rotational latency when the disk will move below that head. So the track remains same, that means no movement of the head, only the disk is moving below that particular head. So if sequential blocks are being read, then there is no head movement. Only when the last sector of one cylinder has, so if B plus 1 has been read, then B plus 2 has been read, then B plus 3 has been read, then the next block has also been read. And now if we want to go to the next block of the next track, then only the head movement is needed. So the head moves from one track to the next only if there is a movement required from the last sector of one cylinder, or you can think of cylinder as the track or a track at the same radial distance to the first sector of the next cylinder. So the number of disk seeks that are required for accessing these contiguously allocated files, this is minimal. So what are the problems in this contiguous allocation of space to files? Problems is that we have to find the space on the disk for a file. So if it is a large file, then finding those contiguous blocks on the disk, that becomes problematic. So if there is a file which is requesting a size n, that means it is requesting n blocks. So how to satisfy this request from a list of free holes? So if you see at this, in this figure again, you can see that this is a hole of contiguous blocks. This is a hole of 4 blocks. Again we see a contiguous block of 6 blocks over here, contiguous 6 blocks, continuous 2 blocks over here. So these are free holes which are available, and if there is a request for, let's say, 2 blocks, then what kind of an algorithm should be done? Should it be first fit? So if it is first fit, then this particular block will be used, which is out of these 4 blocks, 2 will be allocated. If it is the best fit algorithm, then the whole list of free blocks will be searched, and we will find that here is a block which is having only 2 blocks, and that is the request. So the best fit algorithm will allocate these set of contiguous blocks. But if there was a request for, let's say, 7 blocks, then how will that be satisfied? So as the files are being allocated and deleted, this free storage space is broken into little pieces. So this is this external fragmentation. If we look over here, we can see that here is a block of 4 free blocks, here are 6 free blocks, and here are 2 free blocks and 1 single free block over here. Let's say there was a file which was requesting 8 blocks. We do not have 8 contiguous blocks available in this scenario, because this whole storage space has been fragmented into little small holes. Even though there are 4 blocks available here, 6 over here, 2, so the total is more than 8, but 8 contiguous blocks are not available. So this external fragmentation now is a problem. So there is a need for compaction. So in this case, all the holes are brought together on one side so that that becomes a larger block from which now space can be allocated. Another issue with contiguous allocation is knowing the size of the file. Does the creator know initially the size of the file to be created? There may be a possibility that at the time of creation of the file, the size is not known. So if too little space is allocated to the file, then the file may not be extended. In this case, there are two solutions now. Solution 1 is that now this user program can be terminated and an appropriate error message can be given to the user. So the user will then be allocated more space and then the program will be run again so that the file of a larger size can be created. Now running the program again when it was already running, so stopping that program and running again, it can be a costly affair. Solution 2 is that a larger hole is found and then the contents of the file which is already present is copied to the new space and the extra space can be used by that file to grow and the previous space can be released. So this series of actions can be repeated as long as space exists. That means if now the file requires still more larger space, again a larger hole has to be found and the contents of the file have to be copied to the new space. So this can be a little time consuming. Even if the total amount of space that is needed for a file is known in advance, pre-allocation may be inefficient. Why is that? Because even if we know that ultimately this file is going to take a large space and if we allocate that space to that file, but this file is growing slowly over a long period, but still it is occupying that large space. So much of that space is unused for a long time and therefore we can say that for that particular point in time where till the time that file is not using that allocated space, there is a large amount of internal fragmentation. That means whatever space was allocated to that file, a lot of that space is lying wasted. So there is a modified contiguous allocation scheme also, where a contiguous chunk of space is allocated to the file initially, and if that amount of space is not large enough, then another chunk of contiguous space known as extent is added. So now earlier what was being done is that suppose a file required, initially it was given 4 blocks and now it required 6 blocks. So a larger contiguous space of 6 blocks was looked for and these 4 blocks were copied to these 6 blocks. Another way of doing it, that if it needs another extra space, then another 2 blocks will be allocated which will be contiguous. So this is an extent of this original file and the location of the file's block recorded as a location and a block count plus a link to the first block of the next extent. So in the information that is being stored for the file, the first blocks, the address of the first block of that file as well as its count, that means the size of the file which is 4, as well as a link to the next extent, this is also stored in the information. So on some systems the owner of the file can set the extent size. If the extents are too large, then internal fragmentation can be a problem, which we saw just. And now Also, if extents of varying sizes are allocated and deallocated, then holes again will be formed and which will lead to external fragmentation. But the only thing is that now a contiguous space of 6 blocks does not have to be necessarily looked for. So this was all about contiguous allocation. We will take a look at linked allocation in our next video.